Good afternoon, everyone. It's a great honor for me to stand here and introduce my research. And my research focuses on open energy balance. And we conducted a series observation and simulation in Guangzhou, which is a humid subtropical city. Let me simply introduce myself. My name is Yurong Shi. I'm postdoc in Sanyafang University, and in next month I'm going to Concordia University in Canada to continue my next postdoc. As we know, in urban area with the increasing impervious urban land surface and the limited vegetation and mainly human activities, so there are significant increases in urban land surface and the air temperature. There are significant increases in land surface temperature and the air temperature. That is what we call urban heat island or surface urban heat island. So because of this, we will see mainly urban problems such as increasing heat wave events and increasing energy consumption from building and traffic. And because of this, we also can see mainly more mobility and mortality. So we need to know the mechanism of urban heat island from Oker's classical depiction. We know that urban energy balance can explain the mechanism of urban heat island. The main cause of urban heat island include increased absorption of solar radiation and increased anthropogenic heat and increased heat storage in urban area and decreased evapotranspiration. This is really the motivation why we want to study urban energy balance. Up to now, there are many turbulent flux observation around the world. For example, on the Urban Plumber project, it contains 20 urban sites. The climatic category include tropical, tri-temperate, and continental. But there is a climate that did not include yet. That is a humid subtropical climate. So there are only a few surface energy balance observation in humid subtropic climate. But in this region, the urban thermal environment is also severe because in this region the summer is long and the weather is hot and humid. Um, so up to now, we don't know the daily and the seasonal characteristics of urban surface energy balance in such hot and humid region, and what are the main contribution to local urban energy balance. And on the other hand, there are a lot of many surface energy balance, or we call urban canopy models. But are they suitable for this climate? We need further to evaluate. This is our study site. We conducted a turbulent flux observation in Guangzhou. And from the map, you can know it is surrounded by compact high-rise building, which belongs to LCC1. And to meet the requirement of evaluation of urban climate model, we thoroughly control the data quality and calculate source area and follow guidance on turbulent flux observation from WMO. For example, the measurement head is within the internal boundary layer and above roughness sublayer. And the instrument, we use the AD covariance system. Actually, we conducted twice in this study site. In the first time, we conducted for 3 months observation, and in this period, we focused on the influence of different sky conditions on the surface energy balance. Mm. And it turns out the net radiation, sensible heat, and heat storage and albedo and the bore ratio all present a consistent order from large to small that is clear cloud and rainy days. But only latent heat show different order that is raining, clear, and cloudy days. That is because it is affected by precipitation and net radiation. By comparing with different oversight in different regions, we found that almost every surface energy term is related to urban density. Urban density is a product of mean building height and building density. Only two ratios related to vegetation, and these two ratios have the latent heat term. So in 2020, we restarted the turbulent flux in this study site for a longer time, almost covering a year, and we found that the seasonal variability in this study is more for net radiation and sensible and heat storage. Only the latent is an exception because he shows large in summer than other seasons. This happened because the synthetic effect of precipitation and radiation. That is mean when we fully consideration the evaporation process in this area seems to be a more effective um, mitigation strategy for overheat island in this area. We further analyze the two important urban energy terms about the monthly feature, and we know the critical influencing factor. The latent heat is affected mainly by the precipitation, and for the sensible heat flux, it not only affected by urban surface property, it also decided by the boundary layer heat. For example, in the February, it showed the largest value for boundary layer heat, led to the high value for sensible heat. Even though February in this climate is a cool month. Apart from high tower observation, our team also conducted some scale outdoor measurement in Guangzhou, which located in suburban of Guangzhou. And in this experiment, we also measured turbulent flux, and we also measured surface temperature and air temperature. I will give more introduction about this experiment results in following up presentation. After we collected a comprehensive data including turbulent flux and land surface parameter from GIS database, then we use this data to evaluate some urban climate model. Up to now, using our observation data, we and our collaborators have evaluated this surface energy balance model, or we call urban canopy model, including LUMS, SUS, and Wolf BP. From the result of LUMS, the result as shown in this figure, and you can see the net radiation and the heat storage. Heat storage are simulated where while the sensible heat is a little bit overestimated and the latent is underestimated. Then we use scale outdoor experiment data to evaluate SUS model. It turned out the net radiation, heat storage, and the sensible heat all of them simulated where with high evaluation indexes, but the result did not show in here, but you can see the daily circle matched where. Because in this experiment period, we did not consider vegetation. So we only evaluate latent heat in rainy summer days. And the results turn out R square is zero point 0.7 for latent heat flux. But when we compare with the result of sensible heat and latent heat together, the simulation performance is improved with the R square rise up to 0.87. That is mean more accurate partitioning of the two turbulent process of sensible and latent heat is important for improving this kind of urban canopy model. And the over high tower measurement data also used to evaluate a BP model. This study is conducted by one of our collaborators, Xing. She also gave a presentation in this conference. And shows the similar result. That is, there is a overestimation of sensible heat flux and underestimation of latent heat, but the deviation are basically within one standard deviation. Let me simply summarize my presentation. We conducted the surface energy balance model in humid subtropical climate, which can reinforce the global dataset of urban surface energy balance. And we know the daily and the seasonal characteristics of urban surface energy balance in this area. And we give some suggestions for next step to improve urban canopy models. And in the future, we will use this model to analyze attribution of heat, urban heat island and obtain some quantitative mitigation strategy. If you want to know more some details about this research, you can refer to this reference, and also can send email for me. Thank you for your attention.